Welcome back to the Caribou Data Science channel. This is part 2 of my analysis of New York State's uh, cases and deaths, and also a secondary look at, second but not equal look at 3 New York counties, Nassau, New York City, and Suffolk County, okay? This time is, then we're going to use one, maybe two packages. And normally I would put Benford. Let's start with Benford test, okay? Okay. All right. Now, normally, if I was starting from scratch, I would certainly put everything up here. I mean, we could even do that now, okay? But I think I'll leave it here just so you can see it all in one spot. We still come back up here, run this, and run this, and run this, and run this. Okay. Now let's come down here and take a look. Got daily totals. Okay. Let's start. There's two different packages we could look at. We can use Benford. We can use Benford analysis and Benford test. Let's start with Benford test. Okay. Now, first we're going to create a test set. Okay. Okay. So first we're going to random sample to produce his Benford law. Returns a random sample with an n length that satisfies Benford's law. And again, this is pretty simple, right? Okay. So we're going to say x is let's set a seed. Let's say 421. Now we're going to create a sample set using the R-benf function. Let's go and run this. I wonder if there's a Benford test on GitHub. It hasn't been changed, so it's okay. All right. So we're going to set a seed. Now we're going to create a, let's keep, R-benf, R-benf, and we're going to create a, let's say 500. We're going to create a Benford test set, okay? And we can look back over here. And this is just a series of values, okay? So now let's come. What's G been? Quantile function been? Huh, that's interesting. Let's just do this and see what this happens, okay? Q bin. Yeah. Hmm. That's the one. Allow myself to get a little distracted here, okay? Okay. What can we do? A quantile function, first digits function. Okay. Let's take a look here. Digits. Okay. So now we're going to create two different first digit. Okay. One. Okay. X comma TGS equals 2. So let's do this now. See what happens. All right. Well, those are numbers. Richten. Okay. Let's just call first 2. So let's, if we come over here now, we do T digit. What we get is a bunch of numbers here, a bunch of single digit numbers. Okay. Let's take a look now at the second 2. Let's see, these are two-digit numbers. These are two-digit numbers, okay? So now we now got the first two data sets we need to begin our analysis. So that's what we got here. So now we're going to say this. Well, actually, what we're going to do is this. We're going to say, plot first digits. Benford analysis. Digits. 1. Okay, here's a summary. Here's a digit summary. Frequency. What does the rest of these things mean? Below the graph is a matrix of digits, their relative frequency, and individual p-values. So what we can say here is okay, good. So frequency means the number 1 occurs 29%, 0.4% of the time. Now, what can we change about this here? Let's see. Okay, frequency Boolean value indicating the absolute frequency should be used. Alpha is either vector containing significant levels, color, code, or name that will pass the points. Okay, let's say CI. Let's see how this looks. That's a little better. Red. Okay, this is what's expected here, 0 through 9. Okay, now we're going to take a second plot here. We're going to plot the first 2 digits, I think. Okay, that didn't work quite right, did it? Okay. Let's do this. Okay, this doesn't give us any numbers. Hmm. Okay. Because this should give us, the two-digit numbers, and it does give us all this up here. Okay. So let's just stick with one since this two doesn't seem to work quite as well. Okay. Here's the frequencies. Frequency is 29.4% of the time. Okay. 53.4% of the time. 70% of the time. Hmm. Okay. Now you can look that our test data fits pretty well at the single digit level. Okay. So the two digit numbers are actually better, but it doesn't really seem to want to work as well. So is there anything that says statistical numbers here? First digits function. Possible leading digits. Okay, so that's the first method. And you know what? Let's start with something very basic here, all right? Let's start with the numbers for New York State. We're going to create a single vector. Okay. You know what? That's no state level. Benford. Okay. So let's set another C down here. Not much really necessary, but okay. Now let's come down here. And we're going to take first digits. Okay. So we're going to do DF colon. Let's just call it first cases. Okay. Then we're going to try a Benford analysis. Let's see what happens. Cases. Okay. Now, cases don't look that bad. They're very close to, if you look, the highest ratio is 35 point to 56.2% frequency. Okay. Okay. Now, if you go and you look, you can say, well, wait a second here. In all honesty, let's take a look at this. Okay. Okay. Now, this is interesting. If this is what it's expected, okay, if this is what's expected, then this is the actual. I'm not sure why the gap is so narrow there. But look, the numbers are way above the expected value, which suggests even at this level, there could be something wrong. All right. The question is, what else can we modify here to digits, graphics, analysis, true. Alpha should be, let's just try this here again, shall we? Now, okay. Now, again, the advantage of using a package, you don't have to worry about all this stuff, okay? Let's just come down here now. Let's put this in here. Let's just say first, no. What happened to my cases? Cases, cases. Okay. that example there. Okay, this is cases. Okay, now you can look here. You see, one digit for deaths. So this isn't bad. You can see the right. This is the expected value, I guess, and you can see it fits pretty good. Okay, now let's come down here and take a look at deaths for New York State. Look how different it is. This is this is the expected number here, I guess. Wait a minute, is the red the actual or the expected? Is the red X the actual value then? Hmm. If this is correct, and if this is the expected and this is the actual, well, that's a problem. Because you can see cases look a little bit closer here, okay? So at the most basic level, because the expected is always going to be the same. The New York State deaths are looking a little bit suspicious. Okay? Are looking a little bit suspicious. Hmm. All right. So how long have we? Okay. I think I'm actually going to conclude part two at this point. Okay. This is the most basic introduction to Benford's plot. Okay. Um, okay. Let's just try one more thing here. This probably won't work, but that's all right. Let's change this to 2 digits here and see what happens. Let's see if we can actually get a plot out of this bad boy here. Yeah, so I don't know what that means. Okay. But if the one and two's off, then this is the problem. This is the expected. This is the expected. Look how close the cases are. Now look at the deaths. Okay, that certainly is an interesting conclusion to make. So that's part two. Part three, we'll go down and we'll actually look at New York City County. Okay. Anyway, thanks so much for your time. This is just this Benford analysis on COVID-19. I mean, this just barely scratches the surface. Okay, barely scratches the surface. Okay, of using one package to analyze the first digits. But it's certainly if the red anyway. This one more time. If the red X is the actual numbers and this is the expected set, which it makes sense because it's 31% know what you look for on the first digit, right? Okay, then the deaths are like not even close. In New York State, they're not even close. Good grief. Alrighty. Anyway, I'm not a Benford expert, but I sometimes think the plots speak for themselves. You don't even have to go to the second digit at this point because the first digit isn't remotely close for death. Okay. Anyway, thanks so much for your time. I'm gonna catch you on a later on part three of this report. We take a second look using a different Bedford package.